opportunity to introduce and hand over to Damian Mooney. So Damien Mooney is a remotely piloted aircraft system consultant with Mandela Uni Autonomous Operation Group. And he's going to be giving us a talk on integrating 4IR technology into schools. So Damien, just a big thank you to you for being here today, for making the time. And we look forward to your inspiring presentation and the dialogue thereafter. So over to you, Damien.
Thank you very much for the lovely introduction, and good afternoon to everyone on the panel. There was some talk earlier that my images might be back to front for some of you. I don't know if, do we actually get a thumbs up on this view? Either way. Okay, so you're happy that it's the right way around. Fantastic stuff. All right, my name is Damian Mooney, and I'm affiliated with the Engineering, Built Environment and Technology Division of Nelson Mandela University in Port Elizabeth. In particular, I manage the Mandela Uni Autonomous Operations Group, which is a fancy way of saying we're the drone guys. Let me start by giving you a quick overview of what we do in the Autonomous Operations Group on a daily basis for the students, and then we can get into the topic at hand of drone technology in schools. Right, the Autonomous Operations Lab at the university isn't officially a teaching lab. Instead, it is an incubator to assist students who want to tackle complicated engineering tasks for their masters or PhDs. In a conventional university environment, a student who would like to start a project involving drones would have to start from scratch and build a test platform over the course of a year with limited skills before he could actually start the research part of his postgrad. Very often these platforms are barely functional, and the students don't have some of the fundamental hands-on skills to manufacture a prototype of a new concept. What could be the start of a new platform that could grow as it gets passed on from one student actually becomes a shelf item at the end of the research period due to the poor quality, and then the next student starting again from scratch. This process results in students essentially taking 2 years for a master's and 4 years for a PhD. Whereas ultimately we want to get them through in a year for a master's and 2 years for a PhD. What we do in the lab is offer rapid prototyping skills, anything drone related, and recently renewable energy as well. We started this lab in 2017 and take on up to 12 students a year and help them to develop airborne and ground-based platforms in weeks instead of years. To achieve this type of manufacturing speed of proof of concept designs, we have the expertise of commercial pilots, instructors, aircraft designers, test pilots, RPAS pilots, mechanical engineers, composite specialists, and then the students themselves who bring the passion. It's a team environment where no one project takes preference. Every student has to be involved in all the other projects that are happening at the lab at the same time. In the background video to my left, which has disappeared for a second now, you can see some of the projects we get involved in. A lot of them are just for the fun of it, but you can see a lot of them are aimed at industry as well. All right, back to aerial robotics and why it should be incorporated into the school curriculum. In the past 8 years worldwide, there has been an industry acceptance of drone solutions for surveying, security, agricultural spraying, medical supplies, fire prevention, search and rescue, and public transport, to name a few. This new industry has been referred to as aerial robotics. Over the next 2 years, to spend over $90 million on drone research. And with the lack of training in South Africa at the moment for aerial robotics, we will only see a small portion of those funds. Ironically, South Africa was considered to be one of the world leaders in drone development up until the early 90s, with drones being developed to assist in the bush wars, like the Secret Project, for instance. But unfortunately, we have fallen behind again, which is what we aim to fix with today's chat. Aerial robotics requires 4 main areas of expertise to operate a drone. First of all, obviously, we need the drone itself. We need hardware developers, people able to design and rapid prototype new drone types. Then we need people to fly the drones. We need drone operators and pilots. Specialized pilots who can fly drones in all conditions. That includes line of sight flying with manual control, the use of first-person view goggles for long-range flight and precise positioning flights, and in some situations, base station flying, where the pilot accesses the aircraft through a computer screen and joystick interface remotely. So I'm just going to pause for a second and just see if we can try and get our... no, that light has definitely left the building. All right. The next skill that we need when it comes to drones is the aircraft systems themselves. We need system integrators. We need system integration engineers. A drone itself is only a tool. People tend to focus on the drone, but the truth is it is actually just a tool to get equipment up into the air. When I say equipment, I'm referring to cameras, sensors with specific capabilities that require engineers capable of installing these devices, interfacing them, and diagnosing and troubleshooting them. And then last but not least, we have autonomous operations. A lot of the flights in the future will actually be autonomous flights with the operator not having to do much. We need people who are able to program autonomous flight controllers and control systems through the analysis of positioning data indoors and outdoors. Of these 4 disciplines, only one is truly supported in South Africa, and that is the drone operator himself, in other words, the pilot. Unfortunately, even with the qualification of a pilot, he is not able to fly or add to the economy based solely on that license. He has to operate through an entity who have an operating certificate. For the other 3 disciplines, there are no academic routes or job type of training. On the job training means that as it actually gets to the stage of developing drones specifically for South African needs, we are a buy off the shelf and operate type country. Right, so back into our schools in South Africa. I think the best thing to do is to explain why I'm interested in this. So I'm going to take you back to 2018. It was June from what I can remember. And South Africa hosted the BRICS Future Skills
Damien, your connection is
challenge. This is a competition that involves 5 countries, BRICS being Brazil, Russia, India. 5 countries, they compete against each other every 2 years. In what is classified as future skills. These include skills like aircraft manufacturing, robotics. I was asked to be the South African, and to be perfectly honest, I didn't actually know what to do. How do you actually test the world's drone engineers over a 3-day competition? I realized that as South Africans, we're actually really good at building with our hands from pretty much nothing, and that was actually the theme of the competition. I brought in 5 teams. It was 6 teams. It was 3 South African teams from various universities, Indian team, a Russian team, and a Chinese team. And I gave them the task of designing a drone from scratch, assembling it, test flying it, then designing a base station that the drone could land on. The base station had to automatically lock onto the drone and start charging it. And on the 3rd day, the students had to program their drone to fly autonomously by homing in on Wi-Fi beacons that were scattered around the hall. So it sounds slightly impossible to achieve all that in 3 days from absolutely nothing, considering I actually just gave them plywood and a box full of electronic components. But within 3 days, they had built these drones complete with the base stations. South Africa ultimately took 1st place in that event. As I say, with our hand skills, that's what we do well at. But the Russians were incredibly impressive with the coding part, that part that I mentioned where the drones had to home in on Wi-Fi beacons. The Russians did that within 2 hours. We took the entire day to get it right. At the time, I didn't think too much of it. I thought, fair enough, whatever university that these students attend, they've got good coding skills there.
Yeah.
Then jump forward to 2019. Sorry, are you pausing me there? Am I breaking up? Okay, fantastic. All right, so after the BRICS event in 2019, we jumped to the World Skills event, which was hosted in Russia, the city of Kazan. For those who don't know the World Skills event, truth is I didn't know it either, actually. It's the Olympics of industry. Basically, 85 countries get together and compete in any skill that's out there. And when I say any skill, I do mean from hairdressing to space robotics. I mean from hotel industry to laser welding. This time being hosted by the Russians and aware of the fact that they were so good at the coding, I took a mechatronics engineer with me. He was pretty good at coding, but not particularly for drones. And I expected to see people of the same age. I took a 22-year-old with me. And as I arrived there, the Russians had 16-year-olds. Okay. Nonetheless, the event was pretty much code-based. The 3 days went about programming drones to fly in a simulated warehouse, if you want to call it that. So imagine a room where we've put up obstacles and we have to convince these drones to fly over the obstacles, through the obstacles, and scan barcodes and so forth. So you've pretty much got a drone in a warehouse which is going around doing stock taking for you. These are the kind of tasks the students were given. So a lot of coding involved in that. And again, as you can imagine, for that event, Russia came first. China came second, take into account there were 85 countries. South Africa came third. So we won the first medal for South Africa ever at the World Skills event. I say we, it is a chap called Jacques Velgemoot, who's been one of my students for about 3 years now. Again, I was very interested into how these youngsters know so much about coding. And it turned out that, yes, they actually implement this at their schools already, from their junior schools already. But they do it in a way that I realized we couldn't do in South Africa. It goes about money, bottom line. They have incredible funding there, and they have labs set up specifically for drones at a lot of their schools throughout Russia. So again, I appreciated what was happening there, but I left it at that. I knew in South Africa we probably couldn't do that. Jump forward to 2020. Sorry, correction. Yes, 2020. It was time for the BRICS event again. It was meant to be hosted in Russia, but of course with COVID, I assumed it would actually be called off. Sure enough, the email started to arrive. The event was still happening. And I thought, well, let's see how we do this. Take into account, while we were in Russia, we all had the same drones, we all had the same equipment, we were competing against each other. How can you possibly do that on the other side of the world where nobody had a drone and we pretty much had laptops? But the truth is that's exactly how they did it. They set up the same the same flying environment in Russia. So imagine again a sort of a warehouse with drones in it, and the drones were all parked there, 5 of them. And these drones were connected to Wi-Fi. What that meant was we could actually write code here in South Africa and send it to a drone that's waiting for us in Russia. And through a live YouTube feed, you would actually watch your drone take off and fly through the obstacle course. Of course, very often it would just smack into the nearest wall. But the point is the event actually worked. And I found myself thinking, hang on a second. We're sitting here with our laptops essentially on our beds. There's a couple of drones on the other side of the world, a few webcams and a good internet connection. That's it. It's done. There's a whole drone infrastructure for a fraction of the cost. So from millions, suddenly it's possible to do something like this with, pick a number, 100,000, 200,000. And that's actually a number which is actually workable. All right. And from my side, that's basically how I see this getting into schools. All we really need to do is set up schools and various colleges in the same way. We need, as a university, Nelson Mandela University, we actually want to approach schools, and over 6 days, pretty much two courses each 3 days, we want to train schools how to assemble drones, how to actually work with all the parts that go into a drone, fly the drones, and then ultimately set up a flying environment for them with the webcams and the laptops I mentioned and the internet connections, and have these students code the drones to fly autonomously. The nice thing about this is when it comes to teaching, it tends to fall flat very quickly. If we as a university had to arrive there and present these courses over 6 days, there'd be a lot of interest at the time, but ultimately it would actually probably just fall by the way. But setting it up in an online environment, that means that every school has the same drone waiting there. Every school has laptops and every school has a Wi-Fi connection. They can compete against each other as often as they want. So suddenly, and that's what drives innovation, is actually competition. So our big push now is to see how many schools we can get this into and get them competing against each other. So the next time we go to Russia, we arrive with a team of 30, not a team of 1. All right, and then obviously, what are the factors? How do we ensure that this actually gets into schools? The most powerful factor for me is realization and acceptance in our teaching institutes, and more importantly, in the governmental departments themselves, for both education and industry. The aerial robotics is a booming industry. There's no denying that getting almost every form of industry airborne is one of the biggest pushes right now. We want to get passengers airborne in terms of taxis, food delivery, parcel delivery, medical supply, surveillance, fire control, and search and rescue, it's all getting airborne, and it all requires people to make that happen. At the moment, there is limited development of drone technology in South Africa. We focus on buying the drones, as I said earlier, and flying them for limited financial gain. The rest of the world is ticking all 4 boxes I mentioned earlier. They're designing the drones, they're installing the systems, and they're selling them ultimately to us. We're the last link in the chain. We don't stand to make any money unless we actually get this into our schools. All right, and then once drone technology is accepted as a means of creating economic growth and employment opportunities, the rest is actually quite easy. We don't need millions, we need thousands. Like I said, for less than 200,000, we can take a school from zero expertise to a self-sustained teaching facility with drones and this flight environment that I mentioned. This value of funding, I say that's available. There are various seaters and industry partners out there which can definitely fund 200,000. And the last thing for me is actually teacher interest. What makes our lab work so well is all of us who are in the lab, we love what we do. We love developing drones. So like I said, our fear is that we approach a school and it falls apart 3 months later. But with the right teaching staff involved, we can actually just keep this going forever. With these competitions I mentioned, we can actually keep this going forever. And that is basically how we're going to get training into our schools. I think I'm actually going to end there for now. How are we doing time-wise? 20 past. All right, I think initial questions. I apologize having to read that entire speech. Unfortunately, we had a laptop issue earlier today. So last minute, I'm afraid.
No, for sure. No worries, Damien. I mean, that was really informative. I think, you said, you as teaching staff, you love what you do. And I think I just saw your eyes light up when you started speaking about the experience in Russia and, coming third out of 80 countries. So it's clear that you do love what you do. I think to all our listeners, we are open for questions now. Please don't shy away. Feel free to raise your hand and actually engage and interact. And if you are unable to do that, then I encourage you to use the Q&A box that's now open for questions. So yeah, I've got one question that comes from Alexandria Cow. So the question reads as follows, Damien: when do you think South Africa will be on par with the rest of the world when it comes to drone adoption in schools? So how much time do you think that will take for us to catch up?
That is the big push on my side. There's no reason why we can't have this rolled out in less than a year. In as short as 3 months, I want to have this in most of the TVET colleges. And then ultimately in the schools, it's school dependent how easily how much they believe in the concept. Let's put it that way. So from my side, yes, we've got a mandate to get this into the TVET colleges within the next 12 months.
Okay, great. So the next follow-up question is a good one, and that's from Jacqueline Williams. That says, what qualifications do the school leavers sort of need to enter the TVET colleges? So what subjects should they be doing that will facilitate their entry into the industry?
Okay, I can't comment on the TVET colleges themselves. Unfortunately, I'm not actually working with them at this stage. But what I can say from the course that we're presenting to the schools, I mentioned that there's 2 parts. There's 2 3-day courses we want to present. The first one is drone technology itself, the electronics, the building, the flying of drones, the maintenance of drones, and then the second part is the coding side. So for the first part, we're offering that as essentially a technician's qualification with a certificate after the 3 days. So for that skill, we don't need much actually. We're just looking for somebody who has a scientific mind, but I don't want to say that necessitates having studied some form of physics or really good at maths. We just want somebody who by default at home, they pull things apart, they put them back together. Those are the kind of skills that we need to make drone technicians. When we get onto the programming side, by all means, we do need our maths and science in there, and we do need some basic introductions to programming, but not excessively. It's all on the job learning, if you want to call it that. Okay,
so it's just for the coding where you sort of need a level of maths and science. In terms of target audience in school, so I assume going into high schools as early as grade 8, or you're looking at a grade 10 situation? What's the ideal sort of age cohort?
At this stage, the target market has been for your grade 10s and above, not for any particular reason. It's just that we do support some of the technical high schools at the moment, so they have been our target. But personally, like we saw in Russia, this should be from junior school already. There's no reason why junior school students can't be assembling drones, can't be flying drones. And in fact, we know they are. One of the disciplines of drone flying is called FPV racing. You might have seen that on TV, or maybe even at a sporting event, where we fly drones in a racing format using FPV goggles, essentially screens in front of our eyes, so we can actually see what the drone's doing. And the students are already doing that. They're doing that as 10-year-olds as we speak. So there's no reason we can't get into the junior schools.
Okay, great. I've got another question that comes from Bhavisha Niran. So Vincent from Namek Investment, the plan to go into schools, when are you guys going to implement and at what grades? I think you've answered the grade, so ideally grade 10, but it can be much earlier.
We're happy
Sure.
if a school approaches us and says, we have whatever it happens to be, grade 6, will you come and help us? There's no reason we can't do that. It's more
Okay,
just
so schools can also approach you guys directly to engage and to start introducing the program.
Correct.
Okay, then Sibukazi has a question. She says, I was part of a drone accelerator program in 2009, and my idea was to implement a drone simulated training. The only obstacle is CAA. Do you have any other solutions of getting the RPL to the learners? So recognition of prior learning.
Okay, so now the drone simulator school, I'm not fully understanding what she meant there. And she was doing initial pilot training using simulators. Is that what it is?
Yeah.
What was meant by that?
Yeah.
Okay. All right, yeah, that's something we haven't actually touched on because it's quite a messy subject, unfortunately. When it comes to drones, we are incredibly heavily regulated. In fact, we regulate in this country to the extent that they can't actually even govern it. They've got so many rules. So it's a very messy arena to be in. Having said that, yeah, for drone pilot training, it falls under the Civil Aviation Authority, as you mentioned. That was the CAA, and okay. And to train pilots towards their final pilot's license, you do need to be an official training organization. You have to comply with CAA regulations and achieve quite a few permits before you can get to that point. The reason why we've gone for this style of teaching, what I've mentioned before, the sort of the indoor environment, is there are no regulations for that at all at the moment. So in terms of us approaching schools and setting up flying environments in their school, when I say flying environments, it's the equivalent of a flying cage, if you want to call it. It's quite big. It's about 6 meters by 6 meters with a whole bunch of obstacles in it. We don't have those problems anymore. We can actually do this kind of training without any regulations besides safety itself. So coming back to the lady who asked the question there, yeah, for an individual to follow the route of training pilots to fly commercially, it's a hurdle. Even as a university, we've been busy with our operating certificate now for about 3 years, and that's with legal assistance. So I'm sorry to say she might consider moving into the direction that we're going into now with the schools. Much easier to manage.
Okay. Then I have a question from Mr. van der Merwe. Armand, will drone education and development be something that we can get to the middle age group involved as well, along with the youth of today's time? So I'm assuming that, you could attract 18-year-olds, 20-year-olds. It's never too late to join or to acquire the skill.
Absolutely. This is actually one of those nice skills that sort of almost fits into the, I use the term very loosely, it's boys with the toys, if it makes sense. And I don't mean in a sexist way. It's aerial robotics. Everyone is interested in aerial robotics. As we said, we've got the 10-year-olds who are flying the racing drones, and we've got dad and granddad who have gone out and bought themselves a drone to take photos while they're on the beach. There's a lot of people interested in this, and it's going to be difficult for us to offer it, commercially to non-scholars. It's something we'd really like to do, but at this stage that isn't actually in our scope. just because it's much easier for us to take this to the schools right now. As a university, we're not actually allowed to compete with
Damien, you're breaking up now.
the industry. So we try and actually just push the teaching side of it. For us to actually go out on non-education candidates, we essentially would be charging the money on the side, and that's not really appropriate.
So what would you advise? I mean, if there was a 22-year-old who was interested, what would the best pathway be for them?
Good question. That's the problem in South Africa at the moment. We don't have many paths right now, besides your dedicated engineering disciplines like electrical engineering, mechanical engineering, and so forth. There's no dedicated drone technician training in South Africa right now. So yes, that is something we would like to do. We'll have to do it with a partner, and luckily we do have a mandate to find partners in this industry. So yes, we will take it out to the side essentially and start offering it to the public as well. But right now, unfortunately, for the next 12 months, it will be school orientated.
Sure. Thanks, Damien. And then tell me the master's and the PhD programs, what undergrad is required? So those solely sort of your engineers focus, or what are the requirements to get into the master's?
From our side so far, yes, that's what we've seen. When I say we're taking 12 students a year, then normally mechatronics engineers and then mechanical, and then a few electrical, but mechatronics is the big one at the moment. Mechatronics is a discipline that it's about system integration. It's a little bit of everything, and that's pretty much what drone operating is. It's taking mechanical design, it's taking aerodynamics, it's taking electronics and coding and putting it all together. So the mechatronics guys are generally a bit more suited to it, but like I say, we have a mechanical engineer at the moment who's building an autopilot system for a full-size aircraft. We'd like to include the IT crowd in future, just because from the coding side, I think we could actually learn a lot from them as well. But at this stage, no, we don't have any.
Okay, then I've got a follow-up question from Carol that says, thank you very much for the insightful presentation. It was interesting. Her question is that it's clear that South Africa does well in assembly and building, but it's clear that coding programming is the main differentiator between South Africa and the rest of the world. Do you have any suggestions on how we can bridge the gap within the resources at our disposal?
I think that's actually the main topic of this talk today, is the fact that we need to get it in at school levels already. When you say resources at our disposal, that's basically it. It's this idea of being able to send people home with a laptop and already they can actually be involved. The coding side of the course that we offer, it's also simulator based, but I don't mean the whole thing is simulator based. What that means is students can generate code and they will have a simulated environment on their laptop where the drone will do what they've told it to or not do what they've told it not to do. And if the code works in the simulator, we get to lift it off and take it straight over to a real drone, drop it in there, and the drone will fly exactly the same as in the simulator. So that's very limited resources. Like I say, if we have a good internet connection and we can get reasonably powered laptops to people, that's that problem solved. We honestly need to have 1 or 2 drones scattered throughout the country that these students can access remotely, and we're there. Yeah.
So there's quite a bit of interest from the audience. So we've got Kolani and Luzuko, who says, how can I apply? I'm a mechanical engineer. How can I join the DroneTech? Where should they go? So I suppose, if they wanted to do a master's program or PhD, they would contact you directly.
That would be a good starting point, yes. Like I say, our particular lab at this stage only takes in 12 students a year for masters and a PhD. And you can imagine it's quite fierce competition to get in the door. But if he does contact me and the area that he would like to research is appropriate for what we do, if we bring in students, we pretty much guarantee they'll get their masters or PhD quite quickly.
Yeah. And then Damien, again, here's the question for the program for early school leavers. And I suppose early school leavers are challenged because you're saying, look, it's easier if it's integrated into the schooling system. I suppose, the only option for an early school leaver could be a TVET college.
That's exactly what I was going to say as well. Yeah. I don't say it's the final answer. TVET college is definitely it's definitely one way of doing it. It is tricky now. We are discussing the sort of the people who aren't in education facilities. I think we might have to push a bit soon.
You're going to come back
sooner than 12 months to sort of take it commercially on the side as well. So I think from my side, I'm going to push for about March next year to get this out with a partner. And again, please take down my email address. Don't be shy to contact me, and I'll give people as much information as I can.
Yeah. So, I mean, there's clearly an opportunity with learners who have left school. Either they left school early, or learners who, between the ages of 18 and early 20s, who haven't, followed through on any after school training as yet. Then there's a question from Jacqueline Williams that says, interested to run the program with teachers, what are the costs involved? Are there costs involved? And then a follow-up question to that is also, you mentioned seaters. So can schools contact seaters for funding? And that's from Gesant Gemit.
Yes, in terms of contacting seaters, I must admit, I don't know the exact procedure of approaching seaters for the first time. As a university, we do it quite often through our finance departments, and they are very keen to fund essentially new skill opportunities like this. Just remind me, what's the first part of that question?
The first question is just the cost involved for
yes,
school and any of teachers.
There we go. That's right. Costing. Unfortunately, there is equipment involved. So to arrive with drones at a school, complete with support equipment, I'm referring to toolboxes, soldering stations, flying cages, remote controls, and all the bits and pieces that go with it. There is that initial outlay, as you mentioned, and off the top of my head, I think it's in the region of 160,000. I know that sounds a little bit scary, but in terms of getting funding, that's not actually that bad. There's definitely seaters who will actually fund something like that. So for planning purposes, yes, appreciate that you're probably in the market for about 160,000 to start a program like this at your school, and it can then go up to the 300,000 category, depending how heavily invested you get on the coding side of it as well. Obviously, the junior schools, we might just keep it on the drone technician side, more about building the drones, modifying the drones, and then maybe the high schools and the TVET colleges will go towards the 300,000 rand category, where we're starting to implement high-speed internet connections and webcams and so forth.
Yeah, and if a school was interested in accessing the 6-day program that you spoke about that you guys offer?
Definitely speak to me. We have our finance department headed by Carl Duprier, who will then basically take over the negotiations. And in fact, coming back to the previous question, please contact me in connection with the seaters. We do this Carl Duprier that I mentioned. He's actually very good at actually dealing with the seaters and introducing people to each other. So that might actually be the gateway that people are looking for. But yes, in terms of enrolling in the course or getting the course presented at your school, even as an introductory presentation, just to show you what it's about and show you the equipment, please email me. We'll take it from there.
Okay, cool. And then Damien, a follow-up on one of the new questions from Anonymous is around legislation and the legislation testing aircrafts. Has it held up progress, or has it actually enabled the growth of the sector?
In South Africa, like I said, we are heavily regulated as far as testing equipment goes. So at the university, we have some very large machines. I'm talking sort of 7-meter diameter type machines that lift about 200 kilograms. And at the moment, we are actually being hindered for testing those aircraft any further than indoor testing, which is why we've now moved into this other realm of fair enough, let's actually put the big projects on standby for now, just because South Africa isn't quite ready for us. And let's concentrate on the next generation side. Let's concentrate on the actual ability to build new drones. Let's concentrate on the coding of drones. That once your big drones are approved, by all means, we're ready for them, we can actually go out there and test them. So I feel at this stage, a lot of the drone work will actually be indoors, which sounds kind of almost impossible, but in warehouse environments, that's the big push now. And we keep saying drones as in airborne drones. Take into account what we do. Let's say about 60% of it is airborne drones. The truth is the rest are actually ground-based drones. So what we do in teaching our drones to fly autonomously around obstacles and scan items and so forth, we teach the ground-based ones to do the exact same thing. So learning the skill is appropriate for multidisciplines. It's not just airborne. It's just that the airborne side is the fun one to talk about.
Okay, cool. All right, there are a number of questions around, being in touch with you and your email address, but I'm sure the team will put your email address up shortly. Then there's a technical question. How do I test a fixed wing drone of that size indoors? Very technical.
Yes, I assume when you're saying of that size, you're referring to some of our bigger ones, like the 7 meter and so forth. In fact, there's actually a picture of one of them there with all of us holding on to it. That drone, because of regulations, was actually flown in an indoor environment, a very controlled indoor environment. I don't want to make it sound as if we cowboys here, but yes, we had to do that. We actually found a big warehouse, and we did all of our test hovers and so forth inside it, our power checks and all the rest. The truth is, once a drone is hovering in an indoor environment and is capable of doing everything it can do, to take it outdoors and fly it in the real world, it's just a box to tick, really. There's not much out there in the real world that's any different from the testing environments we do indoors. So that drone in particular, as you see it there, that's a classic example of where we've done all the work, and now we need to find an industry partner who will then take it and actually, with the appropriate permits, will actually go and fly that in the real world. Sure. So that's how we do things at the moment in South Africa. We try and keep it indoors as long as possible, and then right at the end it becomes a commercial venture where you hand it over.
Great. Okay, so I'm not seeing any more questions in the chat. Is there anyone in the audience who'd like to raise their hand and perhaps verbally use their voices asking a question? People are shy today, or just not talking.
We've had a fair amount of questions there.
Whoa, we have a hand. Whose hand is this? Now it's me. Okay, Jacqueline Williams, you had a hand? Go for it, Jacqueline, the floor is yours, but you must put on your camera.
Okay, I must put on my camera.
Okay, you don't have to.
Okay, now, I just wanted to ask, since that you said that some of the coding, and I'm also trying to now also start the coding club with some of the high school learners, but if you look at coding, the earlier that you get learners to do it, actually the better it is. So some of the coding part of what you guys are doing with the drones, is that available to the schools, or is that in the package that you have that schools have to purchase from you?
Well, funny enough, we actually had a conversation just before the seminar started today. There are quite a few other groups out there who are doing block coding type courses now for students related to drones. I don't know if you've partaken in any of those events like your Lego Robotics and so forth. There's quite a bit of that happening in junior schools and high schools now, where students are introduced to coding, the initial building blocks, no pun intended, of coding. So yeah, Inspire Africa are one of the groups that are offering that, and that's a really nice course for junior schools to get involved in, just to teach them the basics. Once you've done a course like on the lines of Inspire Africa, by all means, stepping into what we do is actually just is pretty basic. The difference between the two courses, and I speak under correction here, is the Inspire Africa courses are there to get that initial way of thinking, to teach the students the basics of coding related to airborne systems. It's not overly code that you can then take over across into industry and put it into drone and say, right, I need that drone to go fly that warehouse for me. That's probably the main difference between the two courses. We focused on trying to get industry back into South Africa, trying to get drone technology out there in a practical manner. Whereas some of these school courses are there as introductory courses. I hope that helps to explain it.
Okay, no, thank you. It does. We do some of the robotics So that's with the drag and drop systems that we have in the Scratch. But I was just thinking more of your other coding languages. And I know some of the versions are paid for.
Looking for some of the technical. Okay.
Yeah.
In terms of the way we code, it's mostly ROS-based, Robot Operating System. I don't know if you've come across that one yet. It's pretty much a Linux environment that we code in with a lot of Python in the background as well. So it falls into the more high end. We are actually dealing with code as opposed to block coding, which is more modular based. The system you mentioned is that more modular based of sort of sliding units and linking them together. Block based, essentially.
Yeah, those ones, that's what they use with Lego Robotics. But it is the foundation, of course, for learners to get engaged and to understand simple coding language. But that is fine. But if we're looking at like you say, having to compete with on international grounds, I've lived in Europe for quite a couple of years and came back. And even the way that things are being still done at school, it's been stagnant. So the approach has to rapidly catch up because those are games that kids play besides having proper coding in school. That's the extramural activities, the things that we're trying to introduce through your drag and drop and your Scratch applications of coding. Those are the games they play. It's not part of the curriculum that they do at school. So if we really want to kind of catch up, we have to, in a way, also start introducing some of the other coding languages. Yeah, but that's why I was looking for freebie actually at the moment. But thanks so much for the information. I'm going to check out that Inspire Africa now as well.
Yeah, very good, guys.
Thanks very much. There's two more questions. I mean, the one is organizing you to present at my son's school, and I suppose they can contact you directly. So we need, to contact Damien. And then I think you might have touched on this, but what type of drones are included in your school package, and what coding do you teach the students?
Yeah, the drones, we basically use open source drones. Most of the time we actually order them ready built from the Russians in particular. And the only reason we do that is actually just to support them because they've actually done so much work in this field already. But nonetheless, the drones that we supply are, what's the best way to describe them? Size-wise, pretty much about 40 centimeters across, and they stand about 30 centimeters, well, so between 20 and 30 centimeters tall, depending on what equipment we've got on them. These drones are completely modular. What I mean by that is if you had to go and buy, let's say, a brand name drone off the shelf with a camera underneath it, as you know, when you look at those drones, you can tell that when you break it, it's broken. There's no repair on a drone like that. The drones that we use for teaching are completely modular. A lot of polycarbonate structure, a lot of carbon fiber structure, and then all the actual electronic components are readily available off the shelf here in South Africa. When we talk about drones, there's things like speed controllers and flight controllers, but the point is we only use systems that you can actually click on the internet and get the part within a couple of days. The drones themselves, like I said, they are actually open source in design. So the design of the drone we give you so that if you do have access to some sort of a laser cutter or a CNC milling machine, you can actually cut your own parts as many as you want. So as much as we arrive there with these drones, they're valued at about 10,000 Rand each. You're more than welcome to make your own after that. And that's actually what we're pushing for. We don't want to keep coming back to you and selling you another drone or teaching you more things. We actually want you guys to sort of compete amongst each other, building your own drones and compete with each other. The reason why a drone is 10,000 Rand, it's just that for your first drone, we prefer to give you everything. I want to give you all the tools. I want to give you all the batteries, all the chargers, the remotes, cameras, everything we can possibly give you to grow. So yeah, and then so the second part of the question was the coding language.
The coding, yeah.
Yeah. Like I said, the coding language is not necessary depending on what level of school we're approaching. The people who are doing, let's say, their technician's course, they will just learn the actual assembly of the drone, part replacement, flying, testing, and so forth. The coding side of it, like we mentioned, we essentially use a version of ROS. Now, ROS is again an open source language that was designed by Google, I think it was, back in the day, for some of the early robots, and then it just became open source when they stopped using it. So that's all available for free. There's no cost involved in that. We use a simulation environment called Gazebo. That's what I was describing to you earlier, where we have a simulation of the drone on our laptops with real world environment. You can put obstacles in front of it and so forth. That's also free. And then the students do most of the writing in Python. Now, Python's sort of the let's call it the replacement for what Arduino used to be back in the day. If any of you are into coding, back in the old days, it was all about Arduino computers. These days, it's all about Raspberry Pi computers and Python. So most of the coding we do in Python is in Python, with quite a few libraries that we use. So it's definitely not a difficult thing to get in. A lot of the code has been pre-written. We are teaching you how to take parts of code and join them together. It's not quite block coding where it's neat modules. We still have to manipulate the code, but that's what the course is about, is teaching you how to manipulate code.
Okay, cool. There aren't any more questions in the Q&A. Damien, before I close, are there any concluding remarks that you'd want to make in like 10 seconds or 30 seconds?
Okay. Like you mentioned before, this is a passion of ours. We genuinely enjoy spreading the word. We enjoy teaching people about ARPA's platforms, and I think it's in our DNA, it's in our nature in South Africa. We build things, we invent things, and there's no reason why we shouldn't be back there at the top. So yeah, let's do it. Let's get this in at school level and make it happen again.
Yeah, awesome. Damien, from our side, thank you so much for your time. I mean, your passion was clear, your enthusiasm is there. You make it sound simple and easy, but I think, you know, if you love what you do, it just adds so much joy. I think to the audience, for you guys as well, thank you for making the time. Thanks for all the questions. Thank you for engaging. The team behind the scenes will share Damien's contact details and also the presentation. And there's also a post-webinar that you need to complete very briefly for us. But thank you, we wish you well, and we also encourage you to join the session tomorrow that will be focusing on skills and careers in drone technology. So it is a whole new industry that's opening up. There's lots of growth opportunities, and it's exciting. So I encourage you to join tomorrow, and I wish you well. Keep safe, and then see you guys all soon. Damien, thanks so much.
Guys, thank you very much. Lovely idea.
Cool. Take care, everybody.
Take care, everyone. Bye-bye.
Bye.